Hey guys, I am Gautam and welcome to GMX. So this will be a total video series of IIT Jam chemistry examination. So in this video I will be talking about the fundamental particles. This is the topic of atomic and molecular structure. So this is the first chapter, the atomic and molecular structure from IIT Jam chemistry syllabus, IIT Jam physical chemistry syllabus. Because I am not considering the basic mathematical concepts chapter, so I am just taking the atomic and molecular chapter as a first chapter. So in that chapter the first topic is fundamental particles. So basically what is fundamental particles? So till now you know that there is atom. Okay, so what is atom? Atom is the the smallest part. Okay, smallest part of material. Okay, then we get to know that no, atom is not the smallest part. It has proton, neutron, and electron, which makes that atom. So these are the fundamental particles, which makes an atom. Okay. Then now we again know that the proton, neutron, and electrons, these are made of some other fundamental particles. There are other smaller particles. Those particles forms actually these proton, neutron, or electron. So these are the actual fundamental particles, not this one or not atom. Okay, so these generally we know about the subatomic particles. So what are the subatomic particles? Subatomic particles, that means the electrons, protons, and neutrons. These are called subatomic particles. So let's have a look at these uh, subatomic particles. So in 1897, okay, 1897, by the cathode ray experiment by J.J. Thomson, electron was discovered. In 1886, by anode ray experiment by Goldstein, proton was discovered. And in 1932, the student of Rutherford, okay, Sedgwick was Rutherford's student, okay. You know about Rutherford in atomic structure in class 11, 12 level, you know about Rutherford. So as Rutherford atomic model. So Sedgwick, he was Rutherford's students. Okay, so by Rutherford experiment, neutron was discovered. So from this section, now then at that time we knew they got to know that there are two sections in the atoms. Okay, first one is electron, where electron present, those are called orbit, and the second section is nucleus, where neutrons and protons are present, right? So these are called the basic atomic structure, but actually we are discussing about the fundamental particles. That means we need to go to deep. So we know about the subatomic particles of electron, proton, neutron. Okay, but actually these are not the final subatomic particles. Okay, we can get more smaller particles than this. Okay, because these particles are not the smallest one. That's why then we let's discuss a lot of other subatomic particles like antiparticles. This is not the name of any particle. This is a class of particle, right? So antiparticles, that means antiparticle consists of anti-electron, which are called also positron. So this was discovered. Actually the problem was, the what is the problem with antiparticles was, in 1928, you know about Dirac from Fermi-Dirac statistics. So in 1928, Dirac proposed that yeah, there should be some kind of antiparticles, but for that he has to face some kind of criticism, okay, from the other scientific community. So that's why the concept was not accepted at that time. But in 1932, for the first time, by Anderson, positron was detected. That is, which is positron? That means anti-electron. So we know about electron, but this is anti-electron. That means charge of the electron is opposite to that of electron. Similarly, the antiproton. This was discovered by Segre and his associates in 1955. Similarly, antineutron was discovered by Quark and his associates in 1956. Okay, so we know about these antiparticles. So in discussing these antiparticles, we should know another important thing. If you are familiar with the astronomy, like astrophysics like things, those are not chemistry related things, but also some kind of space like things, if you are interested in that, then you know about matter. You have learned about of course listened about this word matter, antimatter. Okay, so what is matter? Matter consists of electron, proton and neutron, the subatomic particles, the previous subatomic particles which we knew. And antimatter, those consists of anti-electron, that is positron, anti-proton or neutron. So when matter and antimatter come into contact, then energy to cause the disaster, that means destruction occurs. So matter and antimatter, that cannot come to each other, come close to each other, right? So we live in a situation, we live in a region where only matter present, not antimatter. So it is thought that antimatter is present in a system, in a direction or in a region where which is far away from us. Okay, so that's why matter and antimatter cannot interact, and that's why universe exists. Okay, that means you can expect that matter, that is positive things, antimatter, that is negative things. Positive something, negative something, that results zero, that means nothing. So here also the situation is same, that matter and antimatter, those creates energy to cause the disaster. That means destruction will occur when matter comes to come close to the antimatter, right? So this kind of destruction occurs. Then another kind of particles were discovered, that is neutrino and antineutrino. So what is neutrino, antineutrino? Those are the neutrino and opposite charged one are antineutrinos, right? So what are that? What is that? So let's have a look at the beta particle. You know about beta particle. Beta particle is such electron which is released from the nucleus. Electron, yeah, electron from the nucleus. That is beta particle, which I called. You have learned all those things in your nuclear physics section in your class 11-12 level in physics. Okay. So these are the beta particles, and beta particle has can have lowest to highest energy. Okay, it can have lowest energy, it can have highest energy. So in between that, other beta particles, different kinds of beta particle, different energetic beta particle may present. So in case of highest energy beta particle, what happens? As I have told you, that beta particles are originated from the nucleus. So nucleus emits beta particle, that means beta radiation, alpha, beta, gamma radiation. You know about that radioactive disintegration. So nucleus disintegrates that beta particle, and as because of the required energy, it conserves the energy of conservation. Okay, for highest energy beta particle. Okay, but for lowest energy beta particle, it cannot conserve the conservation of energy principle. That's why for lowest energy beta particle, some extra particle has to be considered. Okay, in the scientist community at that time, it was thought that some other particles has to be considered which maintain the that energy of conservation. Okay, which, because for lowest energy beta particle, if nucleus loses energy by in the form of radioactive disintegration, then electron will not follow the energy of conservation principle, sorry, conservation of energy principle. Okay, so that's why for lowest energy beta particle, when these particle releases from lowest energy nucleus, then these particles has to be considered. That means these particle maintain the energy of the nucleus. Okay, so these particle and neutrino and antineutrino maintain the energy of the nucleus, so that the principle of energy conservation of energy is maintained. Okay, is followed by the nucleus. Okay, so like these other particles are present, like mesons, hyperions. Okay, so I have made a table which is more important, so you can get that table. Okay, so pause the video and write this table. So this table is basic table. A lot of other particles are present, but this is the basic particles and the most important particles. So if you know about this, then it will be enough to get. So these are the different classes of particles. These are the different name. Okay, which belongs to these classes. This belongs to this class, these belong to this class, these belong to this class. Okay, so their symbols I have written over here, and the rest mass. So you have to multiply these rest mass, so all the rest masses, with the mass of electron. Okay, so rest masses, and finally mean half-life. So there are two terms. First one is stable, then another one is half-life. Stable means they don't show any kind of radioactive disintegration, that means they are stable. And which shows half-life, that means they show some kind of radioactive integration, disintegration, and that's why they show like T-half. Okay, T-half means half lifetime. So after T-half, after a certain T-half, their number of particles, number of nucleus, okay, or number of particles in that system becomes one half of the previous one. Okay, so that which has half life. So these are not stable. Okay, so these are the list of the fundamental particles. So this table is very important. And finally, let's talk about some interesting thing, that is how to denote the antiparticle. We have learned about the antiparticles. I have told you anti-electron, anti-proton, anti-neutron. So how to learn about how to denote the antiparticle. So to denote antiparticle, you know the electron. Okay, so if you denote the antiparticle, then you have to denote like E bar. Okay, so similarly proton, P bar. Okay, so you have to add one bar on that sign, okay, to denote the antiparticles, right? So this is for other particles, this is also true, right? So for nucleons, okay, so we now know that these particles, antiproton, antinucleon, or like electron, proton, neutron, these are the subatomic particles. But there are some smallest particles that now scientific experiments has proved that nucleons means protons and neutrons. Nucleons means which are the particles which are present in the nucleus. Those are called nucleons. So nucleons are made of quarks. So electron, proton, neutron, those are made of quarks, small quarks. Okay, so quarks are the more smaller particle. Those form the other particles. Okay, like electron, proton, neutron. So electron, proton, neutron can be made from the quark particle. Okay, so these are the most finest particles. So these are the basic concepts of fundamental particles. So I have this will be enough for IIT JAM chemistry. Okay, and some basic things. If you are not from physics, then this will be really enough, because in physics there is a topic like particle physics, which is much more important and fast topic. So I am not going into that, but I have little bit interest in that, so that's why I know about this topic little bit. Okay, so that's all about this video. I hope this topic will help you, and the next video series you will get other parts also, other parts for this chapter, atomic and molecular structure, and you will get other things, right? So that's all about this video. Thank you, thanks for watching.